Okay, so we have the Spotify experience, and we also talked about summarizing data last week. So let's combine them. So I learned my lesson from last week from the ID and the secret. So here you put your ID, here you put your secret. And notice I'm actually putting artist name is equal to Chance the Rapper. Okay, so I'm going to analyze Chance the Rapper today. We're near Indiana. We're near Indianapolis. No, wow. Illinois. Chicago. I'm going to keep that. And why not analyze this guy? And so what we're going to notice is that I'm going to do a couple of things. So I'm just going to run this line. It says get artist audio feature. And the reason why I'm putting Chance the Rapper into artist name is so that I can use artist name every single time I want to refer to Chance the Rapper. I think I do only maybe one more time, but still I want to do it that way, just so you all can see another way of working with in programming. Authorization is equal to access. This is a way for us to tell the computer that we have access tell Spotify we have access. Let me get access to it. So I'm gonna run this. I should get no errors. Okay, no errors are coming up. It's still running. It's getting the information. It's done. It's good job, computer. So then what I'm gonna do here is I'm just gonna do head, right, of CTR at Chance the Rapper. And you see it even starts to show up, and so I can just see. And so as you can imagine, I'm not going to be able to see everything here, but it's giving me the first 6 rows. Gives me the different variables, right? And so on, and the different so on and so forth. Okay, so that's pretty cool. We can even do glimpse, just so we can see some of the structure of the data. Even more information. Okay, that's fine. So with that being the case, what we can do is just summarize the data as we mentioned before. But come to find out, I actually created a function within that Spotify package to actually summarize the data. So it's called get artist summary. But before we summarize, let's do a little bit of a recap when it comes to summarizing data. There's the middle, and hopefully you all remember measuring the middle, or the most typical value is the mean or the median. Okay, but when it comes to how far does each value deviate from the center, that's a measure of variability. And a particular measure is called the standard deviation. So how far, to be exact, how far does each value deviate from the center on average? That's the standard deviation. Okay, and so what this actual function does, it actually gives me a summary of all the songs that Chance the Rapper has created. And so what's nice is that I'm not even utilizing this data frame. I'm utilizing the function to get that information. So if I just run this, it should take some time. It's fine. We can be patient. And so what it's going to do is actually going to go to this data frame and find the actual mean and the standard deviation of all the quantitative variables. Okay, hopefully you see that I'm adding all the vocabulary together now. Okay, so I'm finding the standard deviation and mean of all the quantitative variables. You know what? I'm actually going to show you all this data frame. Give me a moment. Here we go. So when it comes to these variables, you see it says danceability mean, danceability standard deviation. You can easily ask me, what is danceability? So I love that question. So Spotify found a way to algorithmically quantify the danceability of a song. So I looked it up on a website. They're able to do that. Same thing with regards to energy. I think loudness that's definitely a mathematical equation that's not crazy to calculate. Speechiness is the amount of text. And it's actually really interesting, just on a side note, because we kind of have time during this video. During the summer, we actually were able to notice that they actually have data parsed by every 28 seconds and measuring these different variables such as danceability, energy, and speechiness. So they do their due diligence, but sometimes I still question their numbers. So that being the case, that is the summary. It gives you the mean, which is the measure of the center, as well as the variability, how far does the data point deviate from the actual mean, the center. So what we can then do is start talking about visualizing the data so that we can understand what does the distribution actually look like? What is the distribution of the data? Okay, so we talked about the center, we talked about variability, but what does the actual distribution of the data look like? So give me a moment. So there's two ways that we're going to actually visualize data in today's data science thinking. It's the histogram and the density plot. So I would argue histograms, you've probably seen it before. We're working with a quantitative variable. Remember, we're working with a quantitative variable. When it comes to this quantitative variable, we're actually going to create bins and actually determine the number or how often a particular number occurs within that bin. And so I'm pretty sure maybe you did this in your stats class or maybe in high school and you did it by hand, but we're not doing that here. Okay, so when it comes to a histogram, let me actually just go ahead and show it to you what it looks like. So there is some code that you're seeing right now that doesn't make much sense. Let me just explain myself in a moment. So here, I want to create a histogram of the energy variable. And so let me explain what's going on in this situation. So this $sign is extracting this variable from the chance to wrapper data frame. Okay, so it's extracting it. So it's actually going to take it out of the data frame, just like that. So these are all the chance to wrapper songs in terms of the energy. And so why do we need to do that? And the reason why we're doing that is so that we can gain access to the energy variable and then for us to plot the histogram. So once I run this code, it gives me the histogram. Okay. So this is the histogram of the data. And so what I was saying before is that it creates these bins and it figures out the frequency of songs that occur within each of the bins. So this is the distribution of the data. So how do we describe the distribution of data? Give me a moment. Let's take a step back and talk about the density plot. A density plot essentially gives you the same information of a histogram, but it's just smoother. It's just smooth. Rather than looking at just all the blocks, it just gives you a line that represents the distribution of the data. Okay. So here, I'm doing the same exact thing. It says energy info, density. So it's creating this density of this information, and then we're plotting it. It's a good opportunity for me to mention, and as I was coding this, I'm like, those who know statistics, this is a really antiquated way of coding with visualizations. Right now, I'm just trying to talk about it. As we progress, we'll do some more fancy stuff using ggplot. This is just more so for those who are familiar with it. But this is just for us to get acquainted with visualizations in general. Had to say that. So this is the smooth version of this actual of this histogram. So this just gives us the distribution of the data. So when it comes to actually describing distribution, there's a lot of different descriptions that we can traditionally use. Here we have negative left-skewed, meaning that our tail is to the left. Positive right-skewed, that means that our tail is to the right. And then a symmetric means that it's just symmetrical. It's right. The mean and it's not correct, but it's right. It's not skewed. It's not skewed. And so when it happens to have some skewness within the data, whether it's positive or negative, that tells us that there's outliers, meaning that there are numbers that are deviating dramatically from the mean. So whenever we see outliers, or wherever there's a lot of outliers present in our data, it's possible for our data to be skewed left or skewed right. Okay, so we looked at energy. We have time. Why don't we just let's look at something else. Let me think about it. I got ahead of myself. Before we go change the variable, actually, let's just describe this. I would argue this could be symmetric, slightly skewed left, right? Because it seems as if there's a little bit of a tail to the left. But if we're generally speaking, I would say this is relatively symmetric. Okay, relatively symmetric. And one of the biggest things for those that want to go down deeper in statistics, or has gone down deeper in statistics, these kind of assumptions of normality or symmetric, therefore potentially normality, means something deeper in statistics and machine learning. So that's something special to note. So let's look at something else. I actually tried a bit. I know there's another variable that looks a little bit different. Loudness. Okay. So one would argue this is obviously skewed left, right? There's some outliers definitely here in terms of the loudness of some of these songs. I wonder which songs these are. Let's try in terms of the density plot. Okay. And watch, I'm going to be... Okay, and I'm going to actually change this as well, just so that I'm consistent. I don't want us to make a mistake. Loudness information. Loudness. Okay, and then you can see that it's skewed left. Okay. So that was fun. And so as we progress, we're going to do more and more of these videos, work more and more with these visualizations, and bring them to life and get a better understanding of the data. Okay. All right, thank you.